Hello. In this video, we will talk about the features of our product. The steel we use in the mechanism and barrel of our product is extremely important to us. We especially want to emphasize this. For the barrel and mechanism in our product, we use 4340 tempered steel. This material is not produced in Turkey. It is a material that costs twice as much as 4140 steel. The reason we use this is something we observe in many materials. Of course, this is also related to the heat treatments applied. When we see products that have cracked here or there, each in a different spot with 4340 steel, and after deciding on the processes we will apply to it, that is, the final processes we will use. Or rather, we are machining 4340 tempered steel. We are machining this material from 10mm rods, not from castings. Casting cracks also occur in cast parts. That doesn't work for us either. In other words, we don't want even a single one of our products to come back to us with problems. After machining the material from the 10mm rod, when machining the barrel and mechanism, heat is generated on the surface. Because of this heat, a difference occurs between the core hardness and the surface hardness of the material. In order to equalize this difference, that is, to match the core hardness with the surface hardness, we 0.25. In other words, we subject the barrel and mechanism to a special process. That is, we subject them to heat treatment. However, in this heat treatment, we apply it from the surface down to the core to a depth of 0 to 25 microns, and it stays in this furnace for 24 hours. Each piece is hung individually and placed into the furnace. The material, in other words, we don't stack 30, 40, 50, or 100 pieces on top of each other and subject them to heat treatment all at once. Why? In this type of heat treatment, the materials on the outside end up harder, while those on the inside become less hard. So for example, here you might get 47 Rockwell, here 42 Rockwell, and over there, let's say 35 Rockwell. Problems like this arise. That's why we attach them one by one. As I said, it stays in this furnace for 24 hours. After 24 hours, we take the material out of the furnace. We dip it into oil, wait for 10 to 15 seconds, and then take it out. As a result of this process, our material, which comes out of the furnace with a mottled color, turns completely black. So there is no paint on the barrel or the mechanism. There is no coating. There is no Cerakote either. I'm scratching it with my fingernail like this. It's filing down my nail. I'm wiping it. There's nothing at all. Why? After machining the material with the tool, the surface had softened, but with heat treatment, we restore the surface hardness and achieve the hard surface again. Now, look at how this mechanism works. For example, let me give you an example. Look over here. There's minimal friction involved. In many products, it starts from here or from there. There are options like that. All of these are designed, drawn, and we produce them directly from the CNC in this state. On any part of our material, whether it's the mechanism, the barrel, or anywhere else, after processing, that is, until it reaches assembly, there is absolutely no filing or sanding done. In other words, in no part of our finishing factory or outside of it are these products subjected to such processes. Let me put it this way. Normally, a part comes out of the CNC in half an hour, but after it comes out, that half-hour part definitely needs to be filed or sanded outside. Filing and sanding have to be done, but for our parts, they come out of the CNC in about 40 to 45 minutes, and we don't leave any chips or burrs anywhere on them. If you look inside, it's absolutely spotless. You can't even see any tool marks on the parts. No finishing process is done on the barrel, the mechanism, or any part of the gun. You can also take a look at the barrel like this. The barrel is also manufactured in-house at our factory. I don't know if I'm able to show it clearly. The cartridge chamber fits in like this as well. A double coil spring is used. This part here is steel. First, you need to remove this to take out the firing pin. Second, you need to remove our latch here. Can you see it like this? I think you can see it. Third, you need to remove the pin here so you can take out the firing pin. This is a model that can have a red dot sight attached. Apart from that, we have a visual pattern for the cooler and suppressor. When I cock it like this while the firing pin is installed, there is a firing pin indicator here. So our firing pin is cocked. It means there is a round in the chamber. Again, when there is a round here, it pops out, as you know. The extractor applies pressure. The top part of the extractor is painted with red paint. This also shows us that there is a round in the chamber, or rather, it indicates it to us. When it comes to the frame, it actually took us 3 years to develop this polymer frame. This, too, is a raw material that's almost 6 times more expensive than what many standard companies use. And it took us 3 years to obtain this material. What did we want? What properties did we want this material to have? Or rather, we had certain criteria. Our first criterion was that it shouldn't absorb moisture. Second, it shouldn't release moisture. Third, it should be impact resistant. Fourth, it should be heat resistant. We were able to find these 4 properties in this material. In other words, these 4 features are present in this raw material. Again, we can't find 4,340 steel in Turkey. It also comes from abroad. As I mentioned earlier, this material is also not readily available in Turkey. It's not a material we can just buy from the shop around the corner. This is also a special material. Again, we have to import it from abroad. This too, the point I mentioned about not absorbing or releasing moisture, is because, as you know, even steel and other materials expand in hot weather and contract in cold weather. So they expand and contract. You know, power lines sag in the summer and tighten up in the winter. Most raw materials, including steel, I repeat, maybe, but they absorb and release moisture. We said it shouldn't absorb or release moisture. Why? We sent it to a temperate, meaning a hot climate. Our material will expand. When we send it to a cold climate, our material will contract. And since the working clearances and tolerances here are very small, no matter what weapon it is, it will inevitably jam or get stuck. When you operate the mechanism, it hits the plastic frame, or in many weapons, we see this part, this section, sagging downward. In other words, we definitely don't want something like this in our weapon. I don't know what special property this material has, but in terms of durability, if a material bends like this, to me, it means it's not a suitable material. The molding conditions for normal materials are between 180 and 220 degrees, but the molding condition for this material is between 280 and 320 degrees. So what does this mean? It means it's a material resistant to high temperatures. So at high temperatures, why do I want high temperature resistance, or why do we want it? No matter how much the weapon heats up during rapid fire, the upper part is made of plastic, and it shouldn't melt, and the material shouldn't be soft because, as you know, with every shot, the mechanism hits this part. What will happen when it gets hit? At high temperatures, the pins will also heat up. When it heats up, this area will start to loosen. Click, click, click. In other words, this hole will start to widen. If it heats up during its forward and backward movement, you won't see any of these issues in this frame. So it's a durable and truly high-quality material. Plus, when I talk about impact resistance, I try to bend it like this. I can't bend it at all. We have one more video. It's a material that we call crack. You know, one that gets pressed and hit, or rather, it's a crack machine. Without this inner frame at its most sensitive point, none of these are present. We strike it here, trying to break it. We can't break it. In other words, we get tired, but the material doesn't. That's why this material is indispensable for us. Again, we do the injection molding of this material ourselves, in-house, in our factory. And after the material is molded, it is in no way attached to any apparatus or shaping device. I mean, with many materials, it's like this. They're held after molding. A clamp is attached here so that this part doesn't come off downward. This part is fixed in a vise like this, so it doesn't move like that. An apparatus is attached to the magazine slot so that this part doesn't narrow or deform. In other words, so it doesn't take on a different shape. But this material comes out of our injection molding machine. It's a part that we send directly to assembly afterwards. It is not attached to any shaping apparatus in any way. The rear pad can be changed. We have 3 pads called small, medium, and large. You can adjust it according to your hand. The magazine catch can be changed to either side. It can be removed from this side and attached to the other side as well. It has an option and feature that can also be used by our left-handed friends. The magazine we use in the firearm is the C75B. In other words, it is a magazine suitable for the C75B firearm, and it is manufactured by Mekar, an Italian manufacturer. In addition, there is also a company called ACT that is also an Italian company. So depending on which one is available for order, or their production status, or their delivery times, sometimes we get magazines from ACT, sometimes from Mekar, these 2 Italian companies, and add them to our product. You might ask, why Italian? From our perspective, it's all about the magazine. If there's a firearm, there has to be a magazine. If there's no magazine, there's no firearm. In other words, the better the magazine, the more it enhances the quality of your firearm. How should I put this? So we made the firearm top-notch, but if our magazine isn't up to the quality we want, or the right dimensions, or whatever, its shape, its form, its ability to hold or feed rounds, if those aren't right, then our firearm just won't work. Since we don't want something like that to happen, what do? If we're using 4340 steel in the mechanism and barrel, we also try to use the best material for the polymer. So this time, we also tried to use the best possible magazine. Overall, this is our safety model, our safety feature. It has a trigger safety. If we press here, the trigger will release, but if we press from the side like this, it won't. Our trigger won't release. This is a trigger safety designed for when we try to quickly draw the gun from our waist. It's a trigger safety made to prevent accidental discharge, so we don't shoot ourselves or the trigger doesn't release in an unwanted position. If I'm going to fire, I will come to exactly this position. When I press the trigger, as soon as I press it, my trigger will release. Other than that, if I press from the side or pull it quickly, it doesn't release. Another thing we pay attention to, or want you to pay attention to, is that even when I completely let go of the slide in this motion, it should still be able to lock in this position. I'm doing it this way because you're paying attention. Can you see any scratch or friction marks here? There aren't any. Then, for example, we have a slight thickness here on the barrel. The reason we put this here is for shooting, to be able to group the 3 points much better and into a smaller area. In target shooting, a red dot can be attached, a laser can be attached. Reset distance. I've cocked it again. If you noticed, it's an ideal reset distance. It's not too long and it's not too short either, because if it's too short, it's actually quite dangerous. Let's say it's as it should be, or rather, it's correct. If you ever come across our gun anywhere, this is something you can't really describe. You have to feel it. After taking up the slack on the trigger, touch the trigger very gently. You can only feel the sensitivity of the surface between the trigger and the firing pin. It never drops with a click, click, click sound. There's a perfectly clean surface. You can tell exactly when the firing pin will release. Otherwise, you're left wondering, did it drop? Is it gonna drop? How should I put it? Something like that? In other words, you'll feel this on the trigger. When you encounter our firearm, we'll ask you to test this. Apart from this, we have 3 types of frings. Or rather, we have 4 colors: black, earth, gray, and green. None of these here are Cerakote coated or painted. If you take a closer look at it from this perspective, when you slice through the raw material, the exact same vibrant color comes out from the inside as well. So I scraped the edge of this gray color with a knife like this. Gray still comes out from underneath. This means we use the raw material directly. In other words, we have paint mixtures. We mix them to ensure the material comes out colored. We don't apply any kind of coating. Thanks for listening to me. Hope to see you again. Have a good day at work.